Hi, everyone. Thank you for showing up for this webinar. This is an interesting topic, mostly because RavenDB is almost incidental to it. And I wanted to give you some taste about what the actual problem is. And it's actually quite simple. Certain actions are perfectly fine in moderation, but if you do too much of them, they become abuse. The problem is, where do you draw the line, and how do you even detect that? There is like spam, like emails, spam emails. If I send you one email, hey, remember me, that's okay. If I send you 1,000, that's more than abuse. Let's put it this way. So let's see how we translate in our systems. And I want to give you some history, some actually recent history. So we have this thing. And if you go and execute this, you will end up with a lot of personal details of people, personal details being their email, pretty much, and maybe a name. Now, the reason this is important is that a single email is meaningless. But if you have a million emails, that's actually, well, that's useful. That can actually be something that you sell, not for a lot of money, but interesting. It also puts you at a certain disadvantage. Um, if you're in the EU, if you're in Israel, in the US, all of them have, Argentina also have a fairly good and similar scenario. All of those have fairly comprehensive privacy laws. Now, I know that because I had to deal with those. And that means that, for example, if you have too many users, in Israel, for example, the law says if you have more than 10,000 users, then you have to be registered as the registered database. And there are all sorts of rules you have to follow if you're breached, etc. Now, if I'm hitting this endpoint, am I breached? Well, not really. You get the email and the data that I explicitly share with Gravatar to make it public. But given that you have all of those in the same place and location, that's less fun. There is actually a really good article by Troy Hunt that talks about this scenario. And this is basically an insecure identifier. So you can iterate over all of them and get them. Now, at some point, public data become really, in aggregate, become a breach. And Troy has a great discussion when exactly that happens. About a year ago, there was this whole nonsense with Parallel, and I want to focus on something really specific. Parallel had one endpoint that gave you access to a sequential integer of all of the posts, which meant that the archive team was able to do a distributed attack on the system. And basically, a lot of people start downloading posts, and they generated, as you can see, they gather a huge amount of data. And that's quite interesting. By the way, some of the data is actually publicly available, and it can be quite interesting to run some analysis on that. But look at the number of data items that we're able to get. Now, this is not about security. This is something that people explicitly set to public. But if you allow to gather all of that, you start having a weight of its own. So let's think about, how do we prevent that? How do we handle that? And by the way, this is easy because this is people hitting a well-known endpoint, get a reply, and in aggregate, this is a problem. But this also happens in a lot of other cases. So if you have a free tier, then that's a huge problem. People would abuse that quite a lot. At one point, people hired me to write a sharding layer on top of a SQL Server free edition, because at the time it had a 4 GB limit. So per database, so I had this whole system for sharding the data across multiple SQL Server instances, and I actually had to sit down and do the math and go to the business and say, hey, it would take me 2 months to build this, and it would cost you so and so in complexity and operation. This is the SQL Server license that you want. Do you want that? Okay. Here is another recent thing that happened. This is how Telegram implemented translation. What they've done is to basically hit Google Translate, but there are rate limits, so they had to bypass them. So that's actually quite interesting. I think that one of the more complex systems that I see for rate limits is with Let's Encrypt, if only because I had to deal with that a lot during the process of running RavenDB and RavenDB Cloud. And that one has quite a lot of rate limits on different things, different times, like certificate per domain on 50 a week, or near count per order, 300 per 3 hours. Why not 100 per hour? No, it's 300 per 3 hours. All sorts of stuff like that. Here's a good example, host per certificate. Okay, there is no time here. This is actually really easy to handle, up to 300, really easy to handle. Everything else, a lot less. If you're building any sort of cloud systems or anything that's actually exposed to the web, you have to consider that the network is hostile. What does this mean? Well, what it means is that you have to deal with people who are actively trying to break into your system. Now, the easiest way is, oh, I'm trying to run some brute force on password and SSH stiffing or much of other stuff like that. But even if you have just done APIs, something like this was taken from the Cloudflare documentation, can help you quite a lot. So I only allow 150 requests per minute from this particular location. But think about that. How would you go about implementing something like this? I mean, that's kind of hard. Spend a minute thinking, okay, I just need to know, I need to remember 50 a week. Okay, I can just remember the past 50 or the oldest and the newest and check if the new. That's kind of hard. There is this nice algorithm that you can use called the token bucket algorithm. This is in Python. Here is a class. You can define the rate and the time in seconds. And now in here, this is the key line. This is where we check if we can access or not. And the idea here is that in here, we are adding the amount of allocated resources that we earn since the last check, and all the way up to the maximum rate that we have. And if we don't have enough, then false or true. Not really that interesting, right? But there is a problem here. This works great if you have one instance running sequentially. What happens when you have concurrency? What happens if you're running on multiple servers? For that matter, let's talk about what it means in terms of running on totally different data centers. If we look at something like Let's Encrypt, if we think about modern applications these days, it's very common to want to run in multiple data centers, at least multiple availability zones, which means that we have to consider all of the usual nastiness of distributed computing. So how do we handle that? What do we do? Well, we can try to go crazy about this, but not so much fun. It's also interesting that we can try saying, oh, I'm going to, if I run on 2 data centers, then I'm going to, this data center can have, let's say, On this data center, you can create 25 domains a week per registered domain, and the other one, etc. Doesn't really work that well. So we need to consider something different. But let's consider what is the impact. So we have rate limits that are meant to protect me. So it's kind of important, especially if you're trying to use a underlying cloud resources. For example, I may have some application that allow the user to upload an image and tell me whatever a particular fashionable item is there. For example, find me, for example, I'm uploading an image of a celebrity and it tells me where can I find that dress or that bag or those sort of things. Behind the scenes, I'm using that to some machine learning, visual cloud operation. I'm paying per request. Presumably, I'm making money from people buying that bag or the dress and some royalty or something like that. What happens if I have a malicious user? Well, they can start spawning requests to me, and I would be paying for each one of those requests. Now, on the one hand, kind of important feature. On the other hand, this is not the sort of thing that you really want to think about. This is not at the core of your business. But it turned out that this is actually quite tricky. How do we do that? In RavenDB, there is a feature called incremental time series. And the whole idea is that you can do something like this. Whenever a certain event happens, you can just say, okay, let's increment a particular time series. And this is on the domain and the account and incrementing the relevant values. And the key for incremental time series is that you're allowed to modify them at the same time. Even on the same instance of time, on the same server, concurrently on different servers, on completely different systems that get merged together, all of those sort of things just happen for you. So what happens is that this looks like this. Let's look at some code first. So here we're defining the RavenDB, the document store, the RavenDB instance that we use. We have a domain name and we have an email. And now I'm going to set up the account and the domain. That's these. And now I can do something like this. And do everything else that I need to generate a certificate. And this is what this looks like behind the scenes. Here I have a new order. Let me run this again. And again, and again. And here are all of those values. For that matter, let me try simulating another one at the same instance that I have. And that should have worked. Oish. Here is what happened. This is okay, so that looks like it should have worked. Oh, here you go. Sorry. Missed that it is here. So here is the new value that I have. I'm sorry, the problem was the time zone differences that it didn't match. So now I can add multiple values for this time frame. And all of them get aggregated and added together. I can then run all sorts of queries on that. And here is for this particular minute. This is for another. And that's actually quite interesting because of what this means for me and what I can do. Incremental time series allow me to do this, to increment safely, concurrently, in a distributed manner. But now I'm coming into this. So let me analyze those queries for you for a second. So we are asking for a particular account ID. We are saying for the incremental orders, give me the sum for the last 3 hours. And we're asking the same for certificate registered on this particular domain for the last 7 days. Give me the sum of that. And here's what these queries look like. And let's just ignore this. And now I can see that I have 7 orders for the last n days. For that, so for last 3 hours for accounts. And I also have somewhat less than that for the certificate register. Now, there are other small things to notice. We're doing this lazily, so only here will we actually go and hit the server. Here we can check that we hit the appropriate value. Here we can check the same. We can actually take this slightly higher and ask directly in here to do all of the math and everything, but I think that this sort of thing is much easier to work with and understand. So let's look at this in more details. For this account, new orders, last 3 hours, sum. And this is exactly what we want. Now, this is actually quite interesting. Why is that? Because how are we actually going to handle concurrency? Well, you don't need to. RavenDB is going to handle that. It's going to send all of the right details. And it's going to aggregate them. By the way, here is an interesting factor. Queries on time series like this are transactionally safe. So there is no indexes, there are no stale queries. Everything is going to be immediately accurate. And this is actually sort of an accidental feature. But it turns out that this is really great for implementing time series, even though so this is a really nice feature for rate limits, and even though this wasn't the intent, we just happened to stumble into this when we added more and more features. Now, here's another aspect that is interesting. What happens if I'm running a distributed environment? What happens if I have a user who is malicious and is trying to send a request to the London data center and to the New York data center at the same time, trying to break the rate limits? In this case, I'm assuming that you have 2 separate clusters or even 2 separate databases in separate location that can't necessarily talk to each other quite easily. Certainly not in real time. Maybe a few milliseconds delay or something like that. The nice thing about that is that even though you have that on separate servers, they're still going to merge together. If there is delay or something like that, well, maybe this would be somewhat delayed. It's only show everything that happened on the current server. but it's going to catch up rather quickly. And for most scenarios, for most rate limits scenarios, you're better off failing open. So, oh, I can't talk to the other side. I'm better off letting the user maybe use slightly more than that. So you would issue 51 certificates per week instead of 50, those sort of things, instead of failing that completely. So that's it for rate limits. I'm going to try to do this as soon as we can, not soon as we can, to do the webinar with as much focus as I can. If you have questions, you want me to go into more detail, please raise your hands or ask in the chat. I'll be very happy to answer. So this is it about rate limits. And now I want to talk about another issue. What happens if I don't want to block you? I want you to pay. And this is something that is becoming far and far more frequent with software as a service and general cloud features. So yeah, you may also have rate limits, but in general, far below that, you want the user to pay for their usage. So let's think about how we can do that. And we want to send packets. We want to talk to another server on the network. This is where it gets interesting because we have to understand how networks are used and priced. If you're running inside of AWS, Azure, or most of the cloud providers, you're paying per gigabyte per month. And this is roughly the rate for AWS, for example. And on the other hand, if you're buying network from a provider, you're not paying for the throughput. You're not paying for how much you're sending, not gigabyte formats. You're paying for the capacity. So the maximum megabytes per second that you have. So that actually matters. But let's say that we have this cloud offering that says that you're paying both for peak usage and for the total throughput. How would you build something like this? Well, it turns out that you do something like this. I'm recording for a particular account how much I sent. Now, obviously, this is assuming that you can send all of that in a single instant, but this is relatively close to what I actually want to do. And I had this somewhere. Here we go. So now let's look at this. Here's the code. There isn't much going in here at all. I think that I would need to. Now we're running this. We're just running. It's not really that interesting. And here are some entries here. And now we can start asking these questions. So this is basically just tell me how much I spent for the entire month. I don't even need a group by. So I have 9 for the entire month. Let's go and add something here. This should be interesting. So this is the total that I got for the whole month. Now I can say it like this. Might be easier to look at this like this. Now I can go for every single second and compute how much I meant, how much I paid. Oh, here I see that you're using 150 per second. And in here using 30, etc. That's quite interesting. And this is all I need to do. This is ridiculously simple. And we have a question from Simon. How do you do multiple rate limits? And the answer is just, you do. Ask the question twice. So let's say that what I want to ask is last 10 seconds. This is for the last 10 seconds, and this is actually quite important. You can see last 10 seconds mean exactly that. Since not the, I have to expand it better probably. You can see that this is last 10 seconds from the last value that I have here, not from the last value of right now. If I want that, I have to ask it like this. Something like that. I don't actually remember how to do that in JavaScript. I think this is like this. Yes. And okay, there is something here that assume that I know how to do that. Whatever, something like this. And what this would do is give me the last 10 seconds on a calendar. Now, this might or might not make a difference, but because you might also have to consider, okay, because you might also have to consider different time zones. And now I can do this. There we go. So now this is for the last 10 seconds. This is for the last day. And basically just query over that and get the results and compute whatever this is what you want or not. Now, so we have another question from Simon, and he's asking, how would you make sure you're not hammering the DB for each request if you want to limit on request level? Since you always need to ask the DB and therefore spend time of your valid compute, whereas in this case, you probably want to block earlier. Well, the quick answer is that if you want this to be persistent state, you have to store that somewhere. Now, for RavenDB, let's show 1 second. Here we go. for RavenDB, I'm just going to run this query. A lot. And this is domain name. And the reason I want to show you that is, look here. So we're at 6 requests per second. By the way, the latency to the this server is quite high, so we have to take that into account. But let's make this into well, I really like that C# is a scripting language in this case. And so now we are hitting it quite heavy. I probably need more than this. So we're hitting the server quite heavily. We saw 100 requests per second. I want you to pay attention to the number of requests per second, and I also want you to pay attention to the CPU utilization. So if you're standing at, come on. Okay, so what's the problem? We overloaded the network, probably too many requests. Let's see if I can. That should do it. Okay. So now hopefully we're going to run at a relatively stable rate. And client doesn't handle that. Sorry, I'm running against the remote server and I wasn't actually planning on doing performance tests. What I'm trying to show you, and hopefully this would be actually, no, that should do it. Okay, so now we are running at an acceptable rate. You can see that we're running at 374 queries per second. This is a pretty peaceful machine. And we're not seeing a lot of CPU utilization. 30 to 50% is more than acceptable. And again, this is when we are running a lot of queries. This is actually quite high. Typically, you're not paying on a per query cost for RavenDB, so that doesn't really matter. If you want to, we have scenarios where we are exceeding the tens of thousands of frames per second to RavenDB without really breaking a sweat as well. Not on this particular machine and not when you're running that remotely, but absolutely that's what you can do. So that's not really something that I would worry too much about. Okay, going back to here. So you can see that I'm running, give me the bandwidth, give me the for a particular month, and give me the pics, and now I can scan over that and sum the total money that you have to pay, and then send you the bill. So what I want you to focus on is the impact of this. We are actually making use of a single new feature, the increment on the time series. We have to select the right scope. In the case of Let's Encrypt, that means that we have to add in here new orders for the account, certificate registered for the domain, etc. And then just query over that. You can utilize that for actions. What do I do right now? Or for, okay, here is how I bill you later. All of the data is transactional, all of the data is consistent. There is no need to shell out to some other components. And the entire thing just fit very well into your architecture and behavior. we actually see users who are just using this feature just globally. So I'm going to have, oh, here the number of particular queries that you're running. And now I can give you all sorts of really interesting dashboards. For example, we have users who are looking, oh, you have viewed 60 different tickets these days and you close 7 for the past month and all sorts of other stuff like that. It's actually, I mentioned rate limits and billing cycles, but there is a lot of interest in gamifications. So you have people who are competing for those things. Oh, who is going to top the leaderboards in the number of uh, number of minutes that they spent talking to customer this month and things of this nature. Not necessarily the most healthy things to do, but I'm here now focusing on how I'm enabling you to do things and not what exactly you're doing. So with that, we are short webinar, and this is time for questions. In the meantime, I want to remind you that you can start using RavenDB for free exactly here. Hit here, you get a instance similar to the live test one, except that this one is your own private details. It's going to run the 5.3 release with all of the new features, and we'll be very happy to help, guide, give you additional information about any issues that you have. Just let us know. And Simon, thank you so much for asking all of those interesting questions. If anyone on the call have any more questions, if you remember a question a minute after I close the webinar, feel free to ping us at support@ravendb.net, or you can use this Dundee form. And thank you very much and have a great week.